So to continue with some examples on how to find asymptotes, wholes, and things like that on rational functions, I have an example of a rational function. And while I didn't really put any directions here, the only thing we're really looking to do is to find out if there's a hole in the graph. That's all. So the directions are, is there a hole, which we know is also called point discontinuity. So the way that you would look to do this is first establish the fact that it is a rational function. You know it's a rational function because it's equal to a polynomial over a polynomial. And if you look, you can probably factor these, which you can. What multiplies to -2 adds to 1. There you go. And you can see that you have common factors. And if you remember my notes from over here, where is it? Hold on. Did I go too far? Oh my gosh, I didn't even see it. It's right above. So x minus r is a common factor. That's where the holes are. Point discontinuity occurs at x equals r, where x minus r is a common factor. So that's how you know it's -2. You switch the sign. So there's a hole at x equals -2. If you can cross out common factors, know that it's going to be the opposite of this. Now the hole is at x equals -2, but you need to find the subsequent y that goes with it. So you use what's left over, the x minus 1. So plug -2 in, you end up with -3. So there's a hole there. And that's all we have to do for that particular problem. In terms of finding asymptotes, well, we know vertical asymptotes are in the form x equals some number. So you look to set the denominator equal to 0 and solve for x. So factor first, then solve. That's one of the reasons it's so important to be quick and good at factoring. So if I ask you to find the vertical asymptotes and holes of these, we have f of x equals this over that. I'm going to look to factor. It's a double root if we were to solve that, but I'm just going to write it out twice. And this one factors in 2. And if you see that you can do this automatically, cross it out and know that there's a hole. The hole is at 2. You still have to find the y that goes with it, but you know the hole is at 2. If you plug 2 in to what's left over after this has been crossed out, you end up with 0/3. So there's a hole at 2, 0. The other piece of this is the vertical asymptote. There's a vertical asymptote if you look at the denominator, and you know the denominator cannot equal 0. So that means we have a vertical asymptote at x equals -1. Once again, feel free to go on Desmos and check this out. I promise, it's true. So the vertical asymptote means just that there's this line that goes down the middle, and it's not ever going to touch x equals -1. Ever, ever, ever. Next one. Well, there's no hole. There is nothing to be crossed out. Can't do anything with that. But we do know also there is a vertical asymptote at x equals 3. Denominator cannot equal 3. For horizontal asymptotes, there are certain rules that have to be followed. Horizontal, remember, is a line that goes straight across, so it has a steady height. So it's in the form y equals. And it has to do with the degree. If the degree of the polynomial in the numerator is less than the degree of the polynomial in the denominator, then the horizontal asymptote is y equals 0. If the degree of the numerator is bigger than the degree of the denominator, then there is none. And lastly, if their degrees are equal, then the horizontal asymptote is y equals, you ready? There's not really enough space to write all this. So we have a fraction bar, and it's the coefficient of the highest degree in numerator, that's what the n stands for, numerator, over the coefficient of the highest degree in the denominator. So that's how to find any kind of horizontal asymptote. More to come.